Assalamualaikum and hi everyone. I will continue chapter 10, applications of differentiation, lecture 1 of 2, part 2. The first derivative test. So what is the first derivative test? So let's say, suppose that we have a point C where C is a critical number of a function f that is continuous on the open interval from a to b. So means C is a critical number between a set of real number from a to b. Or you can imagine if we have a real number from a to b, here between A and B we have a critical number here, that is C. Okay, so number 1, if the derivative of f is more than 0 for the interval from A to C, and the derivative of f or f prime x is less than 0 for the interval from C to B, then f has a local maximum at a point C. Okay, for the next diagram you can refer diagram A. Okay, after this we will look at the diagram. So means the gradient is changed from positive slope to negative slope. So f has a local maximum at a point C. B, if f prime x is negative for the interval from A to C, and f prime x is positive for the interval from C to B, then f has a local minimum at point C. Number C, if f does not change the sign at C, then f x has no local extremum at a point C. Okay, take a look at the next diagram. Okay, it is easy to remember the first derivative test by visualizing the diagram below. Okay, let's say C is a point here between A and B. Therefore, if you find out that the derivative of any point from A to B is positive, okay, and from C to B the derivative is negative, okay, negative, so we can conclude that there is one point here that is the local maximum. Okay, B, if the derivative at a point C, at a point, any point from A to C is negative here, and from point C to B the derivative of f is positive, so we can conclude that there is one local minimum point here at a point C. Okay, but if f prime x is positive from the point A to C, and from point C to B f prime x is still positive, therefore we can conclude that there is no extremum. Extremum means there is no maximum or minimum. Okay, extremum means it's either maximum or minimum. So there is no maximum or minimum here because the sign for f prime x is equal, does not change. So what about D? F prime x does not change from the interval from A to C. The sign for f prime x is negative. negative, and from C to B, the sign for f prime x still less than 0 or negative. We follow with example 3. Find the maximum or minimum values of the function y equals to 4x cubed plus 15x squared minus 18x plus 7. To find the maximum or minimum values of the function, we need to find out dy dx first. So dy dx equals to 12x squared plus 30x minus 18. To get maximum or minimum, dy dx must equals to 0, or we can call this as a stationary point. Stationary means it's either maximum or minimum. So 12x squared plus 30x minus 18 equals to 0. Then we factorize to get 6 times 2x minus 1 multiply with x plus 3 equals to 0. So it's either 2x minus 1 equals to 0 or x plus 3 equals to 0. Therefore, we have x equals to 1 over 2 or x equals to negative 3. So we have to determine which one is the maximum and the minimum. So we need to do the first derivative test. Okay, so do the first derivative test. Okay, we will construct a table. To determine the maximum or the minimum point, we need to set up the table for f prime x first. So the domain for the function is from negative infinity to infinity. Okay, but we need to create the interval to be tested here. So we know that negative 3 and 1 over 2 is the critical point. So I draw this line here to represent the line for x equal to negative 3. Negative 3 comes first, then followed by 1 over 2. Okay, then we have to create the 3 interval here. From negative infinity, we need to stop at negative 3. Then the second interval is from negative 3 to 1 over 2, and the last interval is from 1 over 2 to infinity. So we need to pick the value to be tested from negative infinity to negative 3. Let's say I choose negative 4 here. Okay, the value of x from negative 3 to 1 over 2, maybe we can choose 0, and from 1 over 2 to infinity 1. Then you have to substitute this value into dy dx. Okay, dy dx. Then when you substitute negative 4 into dy dx, you will get the answer is positive. So the slope is positive, means it is increasing. Dy dx is increasing like this. Okay, when you substitute 0, the dy dx is negative and it decreasing. Okay, and when you substitute 1, dy dx is positive. Okay, you just write positive, negative and positive. You don't have to write the actual value here. And the sign for dy dx positive, and the slope is going to look like this. So what is the conclusion? The conclusion is the function fx is increase on the interval from negative infinity to negative 3. For the second interval, for negative 3 to 1 over 2, the function is going down or decrease. Okay, and from 1 over 2 to infinity, the function is increase again. Okay, so what is our conclusion from the table here? Okay, from the table, we can see that dy dx, okay, our conclusion here is dy dx, the sign for dy dx is changed from negative, from positive to negative here, to negative at x equals to -3, okay, at x equals to -3, which is this line, the value for dy dx change from positive to negative means, what does it means? It means that function fx has a maximum at x equals to -3. Okay, so we have a maximum point here at x equals to -3. Okay, now we are going to find the maximum value of what is the maximum value. So the maximum value at x equals to -3 means you have to substitute -3 into the function y, and you will get the answer is y equals to 4, y is equals to 4 times -3 cube plus 15 multiply with -3 squared minus 18 times -3 plus 7, and the answer is 88. Okay, so the maximum value at x equals to -3 is 88. Okay, the question asks the maximum and minimum value, means the question asks the value for y here. Okay, secondly, we can see that for the changes for the second interval to the third interval, okay, we can see that fx, the sign for dy dx means dy dx for the second result here, dy dx change from negative to positive at x equals to 1/2. Okay, so therefore, what is the conclusion? Therefore, the function fx has a minimum value at x equals to 1/2. So what is the minimum value? The minimum value is, you have to substitute 1/2 into y, and the answer is equals to 9/4. Okay, 9/4. So this is the conclusion. The minimum value is 9/4 and the maximum value is 88. Okay, we can see from the table here, at x equals to 1/2 here, the sign for dy dx change from negative to positive, means we have a minimum point here. Okay, we have a minimum point here. So what is the minimum point? The minimum point is 1/2 and 9/4, but the question asks what is the minimum value. So The minimum value is, the value for y, that is 9 over 4. Okay, so you have to create the table to determine the maximum or the minimum value. Thank you. Let's continue example 4. Find the stationary point of the curve fx equals to 3x to the power of 4 minus 4x cubed minus 12x squared plus 5, and determine the nature of that point. Nature here means either the point are maximum or minimum. Okay, so firstly you need to find f prime x. Then we have 12x to the power of 3 minus 12x squared minus 24x. Then f prime x must equals to 0 to find the stationary point or to find the maximum and minimum point. Okay, therefore 12x cubed minus 12x squared minus 24x must equals to 0. Then we can factorize here. Factor out 12x. And the remaining here we have x squared minus x minus 2 equals to 0. Therefore we have 12x. You have to multiply with x minus 2 and x plus 1 equals to 0. So it's either 12x equals to 0, or x minus 2 equals to 0, or x plus 1 equals to 0. Therefore we have x equals to 0, x equals to 2, and x equals to negative 1. So these three values, that is x equals to 0, 2 and negative 1, are called the stationary number. Okay, so for each value of x you need to find what is the value for y to get the point. Okay, for these three values you need to find out what is the value for y for each value. Firstly, when x equals to 0, fx will become 5. Okay, secondly, when x equals to 2, you need to substitute 2 into the function, so fx will become 3 times 2 to the power of 4 minus 4 times 2 to the power of 3 minus 12 2 to the power of 2 squared plus 5, and the answer is negative 27. Okay, and lastly, when x equals to negative 1, fx will become 3 times negative 1 to the power of 4 minus 4 times negative 1 cubed minus 12 times negative 1 squared plus 5, and the answer is 0. Okay, therefore the stationary points is equals to 0, 5. Secondly, write in a point form, 2, negative 27, and last one, negative 1, 0. These three values are called the stationary point. Okay, then we need to determine the nature of the function. Means stationary here means maximum or minimum. We didn't know yet until we substitute into the table. Okay, So this is the table that you need to test the value of x. From negative infinity to infinity, this line will represent line for x equals to negative 1. And secondly, this is the line for x equal to 0, and this is the line for x equal to 2. We have three critical value here, a critical number here. Then you have to create the interval negative infinity to negative 1, and followed by negative 1 to 0, then 0 to 2, and lastly is 2 to infinity. Then as usual, you need to pick the value on for each interval. So let's say the first value is negative 2, the second one is negative 0.5. From 0 to 2, let's say I choose 1, and 2 to infinity, I choose 3 here. Then you have to sub negative 2 into dy dx, into dy dx here, and you will get the value is negative. Okay, you have to sub into dy dx, the derivative of y, that is dy dx, then you get negative. And you have to draw the negative, means the slope is like this one positive, this one you get negative, and last one you get positive. Therefore the function is decreasing. The function is decreasing. And for the second one, the function is increasing. This one is decrease. Decreasing, and last one increasing. Okay, therefore when we can see that at x equals to negative 1, the function is decrease and increase. Therefore we can say that there is one minimum point here, and at x equal to 0 we have maximum point here, and at x equals to 2 we have minimum point here. Okay, so that is our conclusion. From the table we can make a conclusion. The conclusion is this point here, that is negative 1 and y is 0 is the minimum point. Okay, and also we have another one minimum point here, that is 2, the point x equal to 2 and y equals to negative 27. So I will combine these two value here, negative 1 0 and 2 negative 27 are the minimum point. What is the maximum point? The maximum point is here, that is, what is the point? 0, 5, and the point 0, 5 is the maximum point. Okay, so from the table we can make the conclusion which one is maximum and minimum. So this is our conclusion. Negative 1 0 and 2 negative 97 are the minimum point, and 0 5 here is the maximum point. Okay, thank you. Okay, now we continue example 5. Find the relative extremum of fx equals to 9 over 5 x to the power of 5 over 3 minus 18x to the power of 2 over 3. So to find the relative extremum, extremum means it's either maximum or minimum. So you need to do the first derivative test here. Okay, so firstly you need to find out what is f prime x. F prime x equals to 9 over 5 multiply with 5 over 3 x to the power of 5 over 3 minus 3 over 3, that is 2 over 3. Then you have to minus 18 times 2 over 3 x to the power of 2 over 3 minus 3 over 3, and the answer is negative 1 over 3. Therefore, we need to simplify 5. 9 over 3, the answer is 3x to the power of 2 over 3. Simplify the second term, you will have 6 times 2, that is 12x to the power of negative 1 over 3. Okay, then you need to factorize. We choose the smallest power here, that is x to the power of negative 1 over 3. We have 3 and 12, you can factorize 3. So the remaining term here is, we have x to the power of 1. 1 means 3 over 3. 3 over 3 minus 1 over 3, the answer is 2 over 3. So x to the power of 1 means 3 over 3 minus 3 times 4, 12. X to the power of negative 1 over 3 we already factorized. So inside the bracket we have x minus 4 only. Therefore, f prime x equals to 3 times x minus 4 over x to the power of 1 over 3. Okay. So our conclusion here, this is a rational function. So firstly we consider f prime x equals to 0. F prime x equals to 0 when x minus 4 equals to 0, that is when x equals to 4. Okay. Secondly, you need to find what is the value of x for f prime x undefined. F prime x undefined when x equals to 0, means the denominator here equals to 0. So therefore we have these two value, that this value is called the critical number. Okay, so the conclusion is, so the critical numbers are x equals to 0 and x equals to 4. Okay, then we need to set up the table. Then we have to draw the table like this, and have to choose the value for x here, maybe negative 1, 2 and 5 here. Then you substitute into f prime x, and you will get the answer. When you substitute negative 1, the answer is positive, and the slope will going up, and this one you will get negative going down, and this one when you substitute 5 you will get positive. Okay, therefore your fx is increase, the second interval is decrease, the last interval increasing. Okay, so you need to find out what is the value of y when x equals to 0. So when x equals to 0, the value for fx is equals to 0 minus 980 minus 0, and the answer is 0. Okay, so when x equals to 4, then what is fx or f4? f4 is equals to 9 over 5 multiplied with 4 to the power of 5 over 3 minus 18 times 4 to the power of 2 over 3, and we get the answer is equals to negative 11 over 11.3. Okay, so from the table here we can conclude that at the point x equals to 0 here, at the point x equals to 0, there is a maximum point here, and at x equals to 4, this line represents the line for x equals to 4, we have one minimum point here. Okay, yes, there is confirmed, we have one maximum point here and one minimum point. So what is the conclusion? Therefore, we can conclude that the point 0, 0 is the maximum point. Okay, and the point 4, negative 11.3 is the minimum point. Okay, so this is our conclusion. So take a look at the question back. The question asks find the relative extremum. So now our conclusion is 0, 0 is the maximum point or maximum relative, and 4, negative 11.3 is the minimum point or minimum relative. Thank you. Okay, now we move to the next part, that is the second derivative test. Another application of the second derivative is in finding maximum and minimum value of a function. Suppose f prime x is continuous on an open interval that contains the point C. A, if f prime x equals to 0 and f double prime x is more than 0, then the function f has a local minimum at x equals to C. B, if f prime x equals to 0 and f double prime x is less than 0, then the function f has a local minimum at x equals to 0. And lastly, C, if f prime x equals to 0 and f double prime x is also equals to 0, then we can say that the test failed. It is inconclusive. Therefore, how to solve? Thus, we must use the first derivative test. Okay. Number 6. By using the second derivative test, find the relative extremum of the function fx equals to x to the power of 4 minus 4x cubed. The question asks you to use the second derivative test. So you have to follow the question. Okay, you cannot use the first test. Okay, now what you need to do is, firstly, you have to differentiate f. We have f prime x is equals to 4x to the power of 3 minus 12x squared. Then you need to factor out 4x squared, and the remaining is x minus 3. Therefore, f prime x equals to 0. Therefore, if f prime x equals to 0, you will get 4x squared is equals to 0, or x minus 3 equals to 0. Therefore, we have x equals to 0 and x equals to 3. Okay, so we need to do the second derivative. Differentiate one more time and you will get 12x squared minus 24x. Okay, then you need to substitute the critical number here, that is 0 and negative 3, into this function, into f double prime. Okay, now I will substitute f prime 0, and the answer is 0 minus 0, the answer is 0. So here f double prime x is equal to 0, we can see that the test is failed. And it is inconclusive. Therefore, we must use the first derivative test. So we need to use the first derivative test. Okay, so just now we test x equals to 0 into f double prime, and f double prime of 0 is equals to 0, which is inconclusive. We cannot say either the point is maximum or minimum, so we need to use the first test again. Then from negative infinity to infinity, you have to check the line here. There is the line here represent the critical number, that is x equals to 0. So negative infinity is to 0 and continue 0 to infinity. Then you will get the value for x is, let's say, negative 1. 0 to infinity, let's say 1. Then you have to substitute into f double prime, f prime x. We have just now the answer is 4x squared multiplied with x minus 3. Then you substitute negative 1 into the function, you will get the answer is negative, and the slope is going down. And when you substitute 1, the answer is also negative. Okay, and the slope is like this. Therefore, our conclusion is the function fx is decreased on interval from negative infinity to 0. What about from 0 to infinity? The function also decrease, going down. Okay, so by using first test also, this is the first test, we cannot conclude either the point 0 x equals to 0 is maximum or minimum. Okay, so what can we see here? We can see that fx, from the first test, we can see that fx does not has a relative extremum. Extremum means either the positive or negative, maximum or minimum. So you can say that f prime does not have a relative extremum at a point at x equals to 0. Okay. Okay, now we will continue. We will substitute x equals to 3 into f double prime x, because the question asks to use second derivative test. So f double prime of 3 and substitute into the derivative, you will get 12 times 3 squared minus 24 times 3, and the answer is 36. 36 is more than 0. So we can say that at x equal to 3 we have maximum or minimum. More than 3 here. We have a minimum relative. Okay, so you need to find what is the value for y when x equal to 3. When x equal to 3 mean f3. f3 means you have to sub 3 into the function fx, and you will get 3 to the power of 4 minus 4 times 3 cube, and the answer is negative 27. So we can say that 3 negative 27, therefore from the result is a minimum relative. Okay.